Welcome to the Architecture Corner. Today we're going to try and untangle something pretty complex, but really crucial. Event-driven architecture, or EDA, and also this idea of coupling in software.
Yeah, it's a big topic. Our goal here is to cut through some of the hype, understand why EDA looks so good on paper, but then look at the real-world challenges and maybe how smart architects tackle them, drawing on some insights from folks like Mario Bittencourt.
Right. Because the promise is huge, isn't it?
Mm-hmm.
Less tangled systems, more resilience when things go wrong. But is it really that simple?
Well, that's the million-dollar question, isn't it?
So let's start with the basics. Systems take input, they do stuff, maybe access resources. In modern stuff, it's usually distributed services talking to each other.
Exactly. And historically, that often meant synchronous calls, right? Like one service sending an HTTP request and just waiting.
Which runs smack into all those fallacies of distributed computing.
Yeah.
Like assuming the network's perfect, which, yeah, never happened.
Definitely not. And that really pushed people towards new patterns. EDA is a big one.
And with EDA, there are kind of two key shifts, right? First, it's about notification. You're not telling another service to do something directly.
Mm-hmm.
You're just saying, hey, something happened, an event occurred, like order placed.
Exactly. And the second big thing is that it's asynchronous. It's fire and forget the service that published the event. It just moves on, doesn't wait for a response.
Which sounds great for reliability.
Oh, it is. That's the immediate appeal. If the network's flaky, you're not stuck waiting. And the publisher often doesn't even know who is listening to its events or when.
So service A publishes an event, and if service B, which normally listens, is down, service A doesn't care.
Pretty much. Service A isn't affected, and Service B, when it comes back up, can just pick up the events it missed, maybe process them in batches. It's a powerful decoupling idea on the surface.
Okay, let's unpack that word coupling. What do we actually mean by it in this context?
Good question. Fundamentally, it's about how much one piece of software, like a service, depends on another. How interconnected are they? And we can think about different types. There's platform coupling, like being forced to use the same, maybe obscure communication tech.
Okay.
Then temporal coupling, that's the synchronous thing we talked about. Services have to be available at the same time to talk.
Which EDA helps with.
It does. And then there's context coupling. This is more subtle. It's about how much services need to know about each other's internal details, like specific API endpoints or, the precise meaning of every single field in a message.
And the goal is always to reduce coupling. Why is that so important?
Well, two main reasons. First, complexity. If everything depends on everything else, it's just cognitive overload for developers trying to understand or change anything.
Makes sense.
And second, the blast radius. If services are tightly coupled, a failure in one can cascade and take down many others. Looser coupling can contain the damage.
Okay, so EDA looks like the answer, right? Loosely coupled, asynchronous.
Yeah.
Zero coupling, nirvana achieved.
If only. This is where it gets really interesting. It's not quite a free lunch. Let's take that example. An order service publishes an order-placed event. A payment service listens for it. Now, temporally, they're decoupled. The order service fires the event and moves on.
Right.
But the payment service still needs to understand that order-placed event, doesn't it? It needs to know there's an amount field, what it means, how to use it.
Okay. There's still a dependency on the contract of the event.
Exactly. Now imagine the business says, okay, for pre-orders, we only capture 10% upfront. The logic for determining what amount to capture might live in the order service.
Okay.
But if the order-placed event still just contains the total order value, the payment service now needs to be updated. It needs new logic to handle this pre-order case, maybe look at other fields to figure out it is a pre-order, and calculate that 10%. The dependency is still there, just shifted.
I see. So even though the order service isn't directly calling payment, a change driven by the order domain forces a change in the payment domain because they share this event contract. Is that the kind of hidden coupling people sometimes miss with EDA?
That's a perfect way to put it. You've shifted the dependency, maybe made it less direct, but it hasn't vanished. EDA introduces its own set of complexities.
Right, it's not magic. What are some of those other challenges?
Well, there are a few common ones. First, out-of-order messages. Depending on your messaging system, like standard SQS queues, for instance, events might not arrive in the order they were sent. Consumers need to be prepared for that.
That sounds tricky.
It can be. Second, duplicated messages. Many systems guarantee at least once delivery, meaning you might get the same event twice. So your consumers have to be idempotent.
Meaning they can process the same message multiple times without causing problems, like accidentally charging a credit card twice.
Exactly. You need logic to detect and ignore duplicates. Third, debugging. Fire and forget is great for resilience, but if something goes wrong downstream, it's not immediately obvious. You're often hunting through logs later to trace what happened.
Yeah, I can see that being tough.
And fourth, just understanding the impact of changes. If you change an event schema, how do you know all the services that might break? It requires good documentation, maybe event registries, things like that.
Okay, so ED clearly isn't simple. It solves some problems but introduces others. What does this mean for actually building good systems then? How do we manage these trade-offs?
That's the key, acknowledging the trade-offs. It's not about finding a perfect pattern, but the right pattern or mix of patterns. Two strategies really stand out.
Okay.
First, focus on reducing dependency cardinality. That's a fancy way of saying reduce the number of direct dependencies. Maybe group services that logically work together very closely, even if it feels like you're fighting Conway's law sometimes. Fewer connections are easier to manage.
Right, consolidate things that change together frequently.
Precisely. And second, consider balancing events with commands. Events announce something happened. Commands are different. They're typically asynchronous too, but they are imperative. They tell a specific service what to do.
Ah, so instead of just announcing order placed.
You might have the order service send a specific command directly to the payment service, like capture payment with the exact amount, say $10 for that pre-order.
Okay, I see. So the payment service doesn't need to know why it's $10, just that it needs to capture $10. The pre-order logic stays entirely within the order service.
Exactly. The command carries the decision, not just the raw data. This can really help isolate changes. Using a mix of events for broad notification and commands for specific actions can give you a much better balance.
That makes a lot of sense. So wrapping up, EDA is definitely powerful. It offers real benefits for resilience and flexibility, but it's absolutely not a silver bullet for eliminating coupling altogether.
Not at all. It transforms coupling. It doesn't magically remove it. You're trading one set of complexities, like temporal coupling, for another set, like managing event contracts and potential ordering issues.
It's about making informed choices and understanding those new trade-offs you're introducing.
Absolutely. And maybe the final thought for you, the listener, is this. The real art of architecture isn't just adopting the latest pattern like EDA blindly. It's about deeply understanding the specific kinds of dependencies it reduces, the new ones it creates, and choosing the right tool, or more often the right mix of tools, for the specific problem you're trying to solve. Always asking why and aiming for clarity and manageable connections.
Great insights, a lot to think about there. Remember, you can check the description for links and more information on today's topics. And don't forget to subscribe for free to the Architecture Corner newsletter over at architecturecorner.substack.com.
Definitely worth checking out.
Thanks for joining us for this deep dive.